Hey guys, hello. I was watching Euros and I went to the gym. So today's video is quite late, but hopefully I can finish the recording in time until today finishes so that I can continue my streak. Okay, contiguous array. This one was a question, yeah, first medium question in a hash using a hash function. Uh, Although the question is just one line, it was really difficult for me. I tried first using a brute force solution, and then later I tried using a hash map, which really didn't turn out that well. So I had to look at the solution, but I will share with you later. So basically, contiguous means that it's adjacent. So if you see here, for the test case num01, the output should be 2 because um yeah, the maximum length of the contiguous array, the array itself is the longest contiguous subarray with the equal number of 0 and 1. And the next one is 0, 1, 0, and the output is 2 because yeah, 0, 1, 1, 0, it has the equal number of 0 and 1, 1, 0, 1, 1, 1. And then it's the longest contiguous subarray. So yeah, there should be two conditions that should be satisfied. One is that it has to be adjacent, and two is that it has to have an equal number of 0 and 1. So let's try to use the brute force approach that I managed in the first try. Let's see. So we're gonna first check all the subarrays. So that will be for start in range. We have to say the length of the array, right? So that will be n equals length of the nums. We're gonna use n here. I'm also really hungry at the moment, so I'm gonna finish this fast in one try and then go get some dinner. Okay, so let's say count 0 equals 0. Okay, we have to define two variables. Count 0, count 1 equals 0 and 0. And for binary array nums, yeah, so if there's a contiguous array, there's going to be an n number, right? And if this n number is equal to the count, then we're going to add 1 to the count 0. And if not, we're going to add count 1, 1. So that is, we're just counting the number of 0 and 1 in the contiguous subarray. So for end in range, start and n, if nums and 0, count of the 0 should add by 1, and if not, oh, maybe someone scored. I hear some noise outside. 1. Now, after we count we make sure that if the count of the zeros and one is equal, we have to update the maximum length, right? So let's do it as how we usually do it. Max length equals 0, and we update the max length once the next tested subarray is maximum. I think someone really scored. Okay, so that will be if count 0 is equals to count 1, then we update the max length. How? By maxing the max length and end minus start plus 1, right? Start is here, and this here, yeah. So that's the current length, and this is the length that we just tested. And then if we find the maximum contiguous subarray, we return that max length. Let's see the whole code. Indentation should work. Please. I'm hungry. Please. Oh, yes. Okay. So we can see that it works. 0, 1, 2. Yeah, yeah, yeah. Great. All right. So if we see the outer loop for start in range n, iterates over all possible starting points of subarrays, and now the inner loop iterates over all possible ending points of the subarrays from the current starting point. And for each subarray defined by start and end, we count the number of zeros and ones. And if the count of zeros is equal to the count of ones, we check if the current subarray length, which is this one, is greater than the current maximum length, and update the max length. And that's how we get it in first try. But now we have to try the hash map version of this. So how do we do that? Let's. Oh, I'm so hungry. Okay, so they initialize the hash map with 0 minus 1. So they initialize the hash map with the base case to handle, I think they handle the subarray starting from index 0. What does this mean? So when the running sum becomes 0 at any point, it indicates that the subarray from the beginning of the array to the current index has an equal number of zeros and ones. So by initializing this hash map to 0 and minus 1, we handle the scenario if the current sum becomes 0 and at index 1, the length of the subarray from the beginning is also index I plus 1. So it's I plus 1, right? So I guess that's why they put it as 0 and minus 1. If I would have tried to come up with this from the beginning, I wouldn't have. But yeah, I'll show you what they did. So max length is still equals to 0, and current sum equals to 0. Now we use the enumerate function. Enumerate is a very handy function in Python that keeps count of both the counters and the index. So for I num in enumerate nums, we update the running sum, current sum 1 if num um, um, equals 1, else minus 1. And then if this current sum in this hash map, the dictionary, we update the max length. So that would be max length, max length I minus hash map current sum. Oh no, this has to be indexed. I'm so hungry. Or else we store the index for this current sum. So that would be hash map current sum equals I. And we'd return max. Oh, please, please, I want to go eat. Oh, fuck. Oh, yeah, index. Let's try this again. I don't think this will work. Check. Yeah, I don't know why this is here. If this has to go here. Let's see. For this also has to go. Come on. Jesus Christ. Yes. Max. Yeah, so we instead use the hash map to update the max length. As you can see, if the current sum is in hash map, we update the max length. If not, we directly store it back to the index. And that makes the time complexity O(n), I believe. And the one that we use, because is O(n) square, because there was 2 loop. So this one is way more efficient, but I would have to do more practice in order to use this. And I believe I will do some more practice tomorrow and day after tomorrow. So in 2 days, I'll finish the hash function. Okay, that was it for today. Hope you guys have a good night, and I'll see you guys tomorrow.